up, you guys, and welcome back to my channel. In today's video I'm going to be showing you how to make one of these awesome handy linear actuators just using a common hobby servo and a couple of 3D printed parts. Now, if you're not familiar with what a linear actuator is or what it does, it's basically a type of gearbox that converts the rotational energy of your motor into a linear motion using either a screw or a simple gearbox system. This particular linear actuator is a pretty standard type, and this one can lift anywhere between 300-400 pounds, while the servo actuators are more limited based on the 3D printed material and the strength of the servo itself, so it is important to keep your expectations realistic. But these are perfect for small-scale robotics projects. They are still pretty strong, so I'm going to be doing a strength testing video to get the exact numbers on that at some point. But they're perfect for small robotics projects or anything that just requires a little bit of motion without lifting an unreasonable amount of weight. So hopefully you'll be able to find it useful as well. I have made this design available for several different types of servos, like the standard ones, just for example like the MG996R servos, which are really common, affordable hobby servos. And this linear actuator here can be built for between $5 and $10, so they're super affordable and really easy to put together. And I also have some bigger ones available for these large-scale servos, and these are going to be able to lift a lot more weight, and they're still a lot more compact than a full-size linear actuator. So they're perfect for robotics applications where you don't have a whole lot of space to work with, or you just want a simple way to add some motion to your projects. One thing I really like about servos versus a traditional actuator like this is that servos, they already contain all your control boards, all your sensors, your motor, your gears. They're basically plug and play. You can just plug them into your Arduino and put your code in right from there. If you're using a DC motor or an actuator or another kind of gearbox, there would be more programming involved. You would need to come up with some sort of motor control board. With a servo, it just comes with all that stuff already pre-installed in the servo itself. Now, a few weeks back, I put up a short teaser trailer that kind of hinted that I'd be releasing a tutorial for a robotic arm that I designed. And that tutorial is still coming. What happened with that was that a few weeks back, my neighborhood was actually evacuated due to the wildfires here in the Pacific Northwest where I live. Look at how red the sky is, just from the fires. They're having us evacuate, I guess, but we'll just see where this goes. It's an adventure. This is the worst apocalypse ever. So while I was out of town for 3 or 4 weeks, I didn't have any access to my computer to upload the tutorial, and it kind of got me thinking about ways I could make that arm just ever so slightly better. So that's exactly what I've been doing, and just making small improvements on the arm before I release that tutorial, but I will be releasing one eventually. So make sure you hit that subscribe button and stay tuned for that. So now that I've gone over the basics of these servo actuators, let's get started assembling one. Your first step is going to be 3D printing the 4 parts needed to assemble these, which includes the outer case, the piston part that goes inside, and the screw that connects to your servo. It is important to mention with this inner screw piece to print it at the highest resolution that your printer can go to. You may also need to scale it just ever so slightly to compensate for any tolerance issues with your printer, but it's important to only do this on the X and Y axis and leave the Z at 100%. Then you'll need to pick up some form of Arduino compatible board or just any kind of servo tester, doesn't really matter which one. I have noticed the cheap servo testers don't provide enough power for the larger servos, so you might want to go with an Arduino for more accuracy. You also need a big long screwdriver, along with the discs that screw onto the top of your servo. And then you'll also need some sort of lubricant. It's really important to mount the 3mm screw that came with your servos inside this servo arm or disc before you put the screw piece on, just so you can screw it onto the top of your servo while the screw is already attached to it. And that's what that big long screwdriver is for. There's a 4mm hole that goes all the way through that screw. So then you can attach the screw to the servo and screw it into place. and just make sure it's screwed on all the way so it doesn't come loose at all. And turn the servo all the way to the left, and this is going to be the closed position for your actuator. These little post pieces are totally optional for you. It was just the way I had come up with to attach it to my robotics project. But if you do want to use these, just make sure that you use really flat head screws so they don't cause any kind of clearance issues. Just make sure it's completely smooth so everything still fits together and can slide around freely. Just due to the nature of 3D printing and the layers, they do create a bit of friction, which is where this lithium grease comes in. And I've found that lithium grease doesn't seem to react or break down 3D filaments at all, so it seems to work really well. So next you're just going to want to make sure that you can move this inner piece around freely without any kind of friction or jamming. And then you're just ready to pop it all together and put all the pieces in the case. Just make sure everything fits and that there's not any extra grease. And you can put the other side on. And then you can screw everything together. All the holes are scaled to M3, but you can just use whatever screws you see fit. And then you're done and you're ready to test your actuator.